Okay, hi Math 10s. This video is going to be for Lesson 5. Lesson 5 for trig is in the workbook on page 235. So everybody wants to be open to that lesson. Make sure you have your calculators out, and let's actually reset our calculators or put them into degree mode. So do your check on your calculator, and your check is the sine of 90. What answer should I get? 1. Oh, look at that. The Math 30s were in degree mode. So we're good to go. What we are doing in this lesson is literally there's nothing new here. We are just going to be now getting triangles and we're going to be solving them. So on your quiz, which is tomorrow, and remember the quiz is going to be on lessons 1 to 6, I'm going to be giving you triangles and I'm going to say solve these triangles, and it's going to be very similar to class examples 3 and 4 in this book or in this lesson, and we'll start when we get there. Okay, class example number 1, we are not going to do all 4 triangles. We are only going to do 2 of these. So let's circle B and C. We will get those 2 done. So B and C. And let's write our acronym. So with everything with trig, we write our acronym. SOHCAHTOA. Actually, I'm going to change that. I don't want to do B and C because I want to do one side, one angle. So let's erase B and let's do C and D for a review. Start with triangle C. They give you an angle. Give that angle a set of eyeballs. This is going to be a review of yesterday. So 69 degrees is my given angle. You label according to that given angle. 126 would be my opposite. Across from the 90 degree would be my hypotenuse, by default adjacent. So now you have to remember, what are we boxing in when we need a side? So we always, whether it's an angle or a side we're solving for, we always have to box in 2 sides. Jack, what would I box in when I'm looking for a side? Yep, side we're looking for. Exactly. Side we're looking for and side we have. That's what we have to do when we're looking for a side. So then I say, okay, which trig ratio has O and H? Ella, which trig ratio do you want me to use? Sine. The sine of my given angle is equal to, my given angle just happens to be, what is it, 69 degrees, is equal to O over H. I'm not going to write O over H. Cohen, what am I going to write? Okay, I need to solve for x. X is on the bottom. Piper, what do you want me to do to get x by itself? Yes, this guy switches with this guy. So x is equal to 126 divided by the sine of 69. Let's look, they want this to the nearest whole number. So 126 divided by the sine of 69. 69 degrees gives me, to the nearest whole number, 135 units. So x is equal to 135 units if we're not given centimeters or millimeters or meters or feet, something like that. Cohen, yes. Write the word units, yeah, because U is actually a mathematical symbol for something else. So write the word units. Okay, D is a review from what we did yesterday. This time we're finding angle X. This is my given angle, but it's not given. We are going to calculate it. So according, though, to that given angle, this would be my opposite. I locate my 90 degrees. 7.2 would be my hypotenuse. By default, that would be my adjacent. Cade, when I'm finding an angle now, what do I have to box in? Exactly, 2 given sides. So I'd be boxing in, when I'm finding an angle, you can only ever have one unknown, right? So I could never box in like O, because I don't know the angle and I don't know O. So I'd be boxing in A and H. And Cade, which trig ratio do you want me to use? Cosine. So the cosine of my given angle is equal to A over H, which is 4.0 over 7.2. I am finding an angle. So Jack, what is this called when I'm finding an angle? Is it a function or an inverse function? Inverse function. So how you would write this on your test tomorrow is you would say, okay, the inverse cos, so I need to see cos -1. I need to see an open bracket, 4.0 over 7.2 is equal to. And then that answer would be inverse cos of, you don't have to type in the 4.0 on your calculator, but 4 over 7.2. And that gives us to the nearest degree would be 56 degrees. So angle X is equal to 56 degrees. What I find, just to sort of give you a heads up, is I find students don't lose any marks for this. You guys are really procedural with writing this. Students get messy over here. And like I saw actually a few of you doing your homework yesterday, and some of you were doing things like this. You didn't have the equals here, and you had the equals here. You get a minus 0.5 if you do that, right? When we are doing the inverse of a function, it is the inverse cos, and you type it exactly as you would see it on your calculator. There's no equal sign here. So the equal sign would not be there, and it would be over here. Okay, let's do this guy. A telephone pole is 11 meters high. Oh, you might want to star this one because I know tomorrow one of the triangles that you're drawing, it's going to have a wire. So something's going to be supported by a wire, okay? So what they say, a telephone pole is 11 meters high. So let's put our telephone pole in there. And that's 11 meters. Is supported by a wire that's 13 meters long. So these wire questions, the wires come out of the pole and they go to the ground. That's how these wire questions will work. So there's my triangle. So telephone pole is 11 meters high and it's supported by a 13-meter wire. So that would be the length of my wire. The wire is going to be the hypotenuse. Always put your 90-degree angle in. If I do not provide a triangle and you're drawing it, I'm going to be looking for that 90 degree. What else does it say? Okay, calculate to the nearest degree the angle between the wire and the ground. So you have to be able to find this. Do they want this angle up here or do they want this angle down here? Holly, what do you think? Up or down? Down, yep. Because if you traced, they want the angle between the wire and the ground. This is the wire, this is the ground. That means they want that angle there. So that gets my X. Label according to that angle, and this would be the opposite. This would be the hypotenuse, and I would box in those two sides. And what we're going to do for number 2 is it says, oh, actually A says, no, we're going to calculate that using trig. What ratio do you guys want me to use between sine, cosine, or tangent? Sine. Yeah. So the sine of my given angle, which is angle X, is equal to O over H, which is 11 over 13. And then I'm finding an angle. So how we're going to type this in is the inverse sine of my ratio, which is 11 over 13, is equal to, Alexa, what did you get to the nearest degree? 58 degrees is correct. Would be your answer. B, calculate the distance to the nearest 0.1. That means to the nearest tenth. That means 1 decimal place is what they want. Between the point where the wire is fixed to the ground and the foot of the pole. So we're not going to do Pythagoras theorem, so let's just redraw our triangle here. So what we had was we were given that this is 11, we were given that this is 13, this is our 90 degree. Put your x where what they're asking for. So it says calculate the distance to the nearest tenth between the point where the wire is fixed to the ground. So the wire is fixed to the ground right here. If I do that in black. And the foot of the pole. That would be the foot of the pole. They want that distance there, which is x. If this was a test question, there's two ways that you could solve this. You could use Pythagoras' theorem, right? You could say, I'll just write it down here, b squared is equal to c squared minus a squared, because this would be my c, right? So we could use Pythagoras' theorem, and maybe we will, but let's first use trig to figure this out. So let's use trig. We just calculated this angle, so I'm going to have to put my 50 degrees in there. So we calculated that angle is 58 degrees. So let's, according to what I just calculated, let's give that angle a set of eyeballs and then figure out what this is using trig. And then we'll verify using Pythagoras' theorem. So if that's 58 degrees, opposite, hypotenuse, and adjacent, I'm finding a side. I box in the side that I'm looking for, so I have to use adjacent. And then, does it matter, you guys, which one I box in? It does not matter. Kieran, which one do you want me to box in? Hypotenuse. Okay, Kieran, based on this, hypotenuse and adjacent, what trig ratio? Cosine. Okay, so the cosine of my given angle, which is 58 degrees, is equal to, cosine is ka, which is a over h, x over 13. X is on top, 13 is on the bottom. Antonio, what do you want me to do? How do I get x by itself? How do I get rid of this divide by 13? Multiply both sides by 13. X is equal to 13 times the cos of 58. To the nearest tenth would be 6.9 meters. Okay, let's double check using Pythagoras' theorem. So using Pythagoras' theorem, I would not be, it is c squared equals to a squared plus b squared, but I'm already given the hypotenuse. So I'm going to use b squared equals c squared minus a squared. So we were looking for this guy here. And my hypotenuse was 13 squared minus 11 squared. And let's just all punch this like in one string on our calculator. So 13 squared minus 11 squared. That is what b squared would be. And then b would be the square root of that answer, which would be 6.9. So tomorrow, it really doesn't matter if you want to use Pythagoras' theorem or trig. I find that most students, when they get used to it, they always use trig. In 20-1, you will never use Pythagoras' theorem. Okay, let's do the last two class examples. This is what you need to be able to do on the quiz tomorrow at the end of the day. So the goal in trig, so we did all of those first 4 lessons to get to this point here. The goal in trig is to solve a triangle. When we solve a triangle, we have 3 sides that you need to tell me, and we have 3 angles. One of your angles, though, is always what? 90 degrees. So really, when you solve a triangle, you really only are giving me, make sure you give me all 3 sides are solved and 2 angles, because one is always going to be 90 degrees. So solving this triangle, you decide where you start. So here's where I would start with this triangle here. If I have an angle, I could solve a side, right? So do you guys want to solve BC or do you want to solve AB? Where do you want me to put my X first? BC? Okay, let's do BC. So let's solve this. Doesn't matter where you start. You're all going to start in different places on your test tomorrow. So according to 37 degrees, X would be my opposite. This would be my hypotenuse. And this would be my adjacent. So if I'm solving for X first, I've got that guy and this guy. Let's write our SOHCAHTOA at least once for this, each question we'll do. Jimmy, between sine, cosine, and tangent, which ratio do you want me to use? Sine is right. The sine of 37 degrees is equal to O over H, X over 33. 33 is on the bottom. Multiply both sides by 33. X is equal to, I'm going to look at the question. It says to the nearest whole number is going to help me with my rounding. 33 times the sine of 37. $20 would be my answer. And I look, and that would be 20 units because they don't tell me. Now, on a test, I'm not going to write X is equal to 20 units. What is this side called? This is BC. Yes. And you'll recognize the question as soon as you see it. Okay. So now I've got 2 out of the 3 sides solved, right? This is 33. This is 20. Now we've got to solve this guy. So what I'm going to do is, again, like erase what you need to, but this is no longer X. So now I'm going to choose a different letter, and I'm going to choose the letter Y here. I'm still using that 37 degrees, so my labels don't change. This is still the opposite. This is still a hypotenuse. And now that's still my adjacent. I do now know that this is 20. But you guys, here's what I'm going to ask. Okay, so I'm going to erase this. So you know how you have to box in 2 sides? So we're solving Y now. So now we're figuring out this side. What would you box in if this was a test question between 33 and 20? Do you know what you'd box in? Cohen, what would you box in? Yes, you'd box in H. Why would you not box this one in, Alexa? Yeah, if I mess this up, I'm going to mess this guy up if I box this one in. So when I solve this side, I have to box that one in because that's my unknown. And then I'm going to pick this because they gave me 33. They didn't mess that up. So then I say, okay, A and H is the cosine. So the cosine of 37 degrees is equal to A over H, which is Y over 33. Again, 33 is on the bottom. Multiply this by 33 and this by 33. Y is equal to 33 times the cos of 37. Which is 26 point, whole number, 26. And then I'm not going to box that in because I'm going to say that Y is really what side? AB. AB is equal to 26 units. I'm pretty sure if I could remember correctly, your quiz, actually it's just right here. I give you units for everything. So either centimeters, millimeters, you just look what the units are. Okay, so now what I'm going to do is I'm just going to erase this one more time. So let's see what I have. BC, I said was 20. AB, I said was 26. They gave me the hypotenuse. I've just solved all 3 sides. Juan, what is the last thing I have to solve in this triangle? This angle C, and that's the name of it. This guy would be angle C. Do you guys know how you would solve angle C? That's exactly what I would do. 180 degrees minus this guy, which is 90, minus this guy, which is 37. Angle C is equal to, if you type in 180 minus 90, that gives you 90. 90 minus 37, are you getting 53? Double check for me. Okay. And then I've solved everything. All three sides are known, all three angles. You move on to the next question. Let's do this guy. Okay, so let's pretend this was a test question. You could, like, this is what, like, the nice thing about trig. All of you might start at a different spot. Somebody might look at this and might say, oh, I'm going to calculate this using Pythagoras' theorem, if it was a test. Or somebody might say, I'm going to start with one of my angles, right? So let's start with an angle. Let's do this guy. I'm putting an x in there because I like using x for my unknown. At the end of the day, though, what is this angle going to be called? It is f, yes. Okay, so if that's the angle that I want to solve for, that's the angle that gets a set of eyeballs, and I label from there. Opposite, hypotenuse, and adjacent. Sebastian, what do I have to box in if I'm solving an angle? O and A, yep, two given sides. Sebastian, what trig ratio? Tan is correct. The tan of angle X, tan is TOA, O over A. So 5.3 over 4.9. I am finding an angle, which is an inverse function. The inverse tan of 5.3 over 4.9. Punch that in on your calculator. They want it to the nearest whole number. Losan, what do you get for that guy? Say it one more time. 47. And then what I'm going to box in is not 47, but I'm going to call that the proper name, which is angle F is equal to 47 degrees. I'm going to erase my triangle. Do you know where I would jump to next? The other angle. Yeah, as soon as I got two angles, boom, you could figure out the third. This guy here, angle D, it's 180 degrees minus 90, minus 47 degrees. Angle D is equal to, Anthony, do you have that one typed in? So 180 minus 90 minus 47, or you could just type in 90 minus 47, because 180 minus 90 is 90. Say that one more time. 43. Okay, so I'm going to erase, put that in. I've got all three angles done. What do you think the safest thing to do to find this missing side? Do you think it would be selecting one of my angles and like labeling according to there and finding X? You could, if you're really confident you did it correctly. I probably wouldn't. How would I do this if I'm not 100% sure if I might have messed one of these up? Pythagoras theorem. Yep. So you could do trig, you guys, and you're going to get their answers right tomorrow. But let's just do Pythagoras theorem, right? Like, let's say we just started there. The only way we could do that if I have no angles is Pythagoras theorem. So that wouldn't be X, actually, with Pythagoras theorem. What would that side be? That would be C. This is my 90 degree, so that's my hypotenuse. C squared equals A squared plus B squared. C squared equals 4.9 squared. It doesn't matter what's A and B in this example. plus 5.3 squared, 4.9 squared plus 5.3 squared. C squared is 52.1. C is going to be the square root of that, and they want it to the nearest whole number. Oh yeah, yes, sorry, it says give all sides correct to the nearest tenth. So we got to look at that. I'll show you where it says that. But if I put in my answer, this would be 7.2 units. So that's what C is, except I'm not going to call it C. This would be, I don't care if you say DF or E or FD. You usually start with the lower letter on the alphabet first, A, then B, then C. So this would be DF is equal to 7.2 units. Alexa, did you have a question? Okay. Make sure you read, because if I would have got this one wrong. So here's where it says it. So if I go back here and if I just erase this, it says give all sides to the nearest tenth is common for sides. And angles, what's most common for angles is the nearest whole number. Okay, so just make sure, like, it's totally acceptable that a question would ask for one answer to be to the nearest whole number and for your side to be to the nearest tenth. That's fine. They could do that. Okay, so for your homework, I've got 1, 7, 8, 9, but I think I had more than that. I'm just looking. No, you know what? I'm fine with that. So let's circle for the homework 1, 7, 8, and 9. And then I'll give you your worksheet to practice. So the students at home are hopefully working on that right now. So 1, 7, 8, 9. And let's check why number 9 says set up. So question 1, 7. So I really like 7, right, for the test tomorrow, and I really like 8. Like if you could do 7 and 8, you're going to be set up for tomorrow's test. Oh, 9. Again. Really good. So we'll set 9 up together. And sorry, you guys, you know what another really good one is actually to see if you are good for tomorrow is this guy. So on the back page, you've got a big triangle and then a little triangle inside. So this is a really good question. And it's basically all of these. So 11 to 17. But and then what you're doing is you're essentially matching. So you're going to figure out what this is, and it's going to be matching here. Let's set up that question 9 because I know this is like a test. Like you're going to get one like this. So you're going to have a couple questions on your test where triangle's not given. You have to draw the triangle. I always tend to draw a standard triangle. All my triangles, when you see I'll give you guys my work solutions at the end of your test. This is my standard triangle, right? I know that they want the angles to be called DEF, and they want angle DEF to be 90 degrees. Which one is 90, Jimmy? E is correct. My 90 degree is E. Then it does not matter. If that is E, this could be D and that could be F. Like as long as you get that 90 in correctly. Then they say EDF is 50 degrees. Ella, which one was 50 degrees according to how I labeled it? D on the bottom. And then according to the way it's all labeled now, DF must be 173 millimeters. So that's my hypotenuse. And you're solving this triangle. So solving a triangle based on a triangle that you drew the picture of. Okay? And that is it for your homework for this lesson. So I'll give you guys time to do that, and then I'll hand out your worksheet.